quick review of what we did earlier. The roots of the quadratic ax square plus bx plus c is equal to 0 are given by minus b plus or minus square root of b square minus 4ac whole divided by 2a. The sum of the roots is minus b by a and the product of the roots is c by a. Important thing is delta is equal to b square minus 4ac. This part b square minus 4ac is called discriminant. If the discriminant is positive, the roots will be real and unequal or different or distinct, whatever you want you can say. If the delta is negative, if the discriminant is negative, then the roots will be imaginary and different. So better to say complex conjugates. And if this quantity becomes 0, if b square minus 4ac becomes 0, the roots will be equal. Real, of course, equal. Important thing is this only. If the roots are equal, delta must be 0 or b square minus 4ac must be 0. Many questions are going to come on this. If b square minus 4ac is equal to 0, the roots will be equal. Otherwise also, if the roots are equal, delta is equal to 0. Now let us solve a few questions now. State without solving. So far what we did, we solved the equations. After getting the roots, we told them these roots are imaginary or real or rational or equal. Now question says without solving you have to determine the nature of the roots. See the first question. Three x square plus 7x plus 2 is equal to 0. A is equal to 3, B is equal to 7, C is equal to 2. I need not write every time, but this time I will write. We have to determine the nature of the roots or character of the roots. What kind of roots you are going to get? Real, imaginary or equal, etc. So for that we should find out b square minus 4ac, determine, that is discriminant. See here, delta is equal to b square minus 4ac, b square minus 4ac, 49 minus 24 is equal to 25 is equal to 5 square, perfect square. Have a quick review. Delta is equal to b square minus 4ac. This is b square, 7 square minus 4ac. This is 49 minus 24, 25, a perfect square. You know, if delta becomes positive, the roots are real. If the delta becomes a perfect square, not only real, it will be rational also. So now since delta is a perfect square includes the word positive. Every perfect square is positive. Therefore, the roots are real because of perfect square, rational and unequal. You can say unequal, you can say different, you can say distinct. This is the nature of the roots required. Going to solve one more question, please have a look. Delta b square minus 4ac 49 minus 80 minus 31, negative quantity. You know, if delta is negative, the roots will be imaginary and distinct. Instead of saying imaginary and different, I have said complex conjugates. You can as well say here complex conjugates. Other questions you please try. I am doing the last one. Third one is left for you for attempting on your own. 2x square plus x plus 3 is equal to 0. Delta is equal to b square minus 4ac. b square minus 4ac minus 23, again a negative quantity, so the roots will be complex conjugates. I am solving one more question, please see. Show that the quadratic equation x square minus 2px plus p square minus q square plus 2qr minus r square is equal to 0 gives real roots. Let us see. We have the quadratic. X square minus 2px plus p square minus q square plus 2qr minus r square is equal to 0. I am rewriting the same equation. Please see very carefully. What I did, I have separated a is equal to 1, b is equal to minus 2p, c is equal to p square minus q square plus 2qr minus r square. Let me write. A is 1, b is minus 2p, and c is p square minus q square plus 2qr minus r square. I am going to work out delta. That is b square minus 4ac. b square minus 4ac understand substitutions. A is equal to 1, b is equal to minus 2p, and c is equal to all that minus p square minus q square plus 2qr minus r square, b square minus 4ac. I am proceeding with the simplification of this delta. This simplifies to very simple work, no explanation needed. 4p square getting cancelled, remaining part is here. It is 4 into q minus r whole square, or so to say, let me write 2 times q minus r whole square. So your discriminant is perfect square. Roots will be real. Of course real. They want real only. So we will conclude by saying real roots. Otherwise, if you have to write the nature of the roots, I will write real, comma, rational and distinct. But the question says, show that this equation gives real roots. Yes, because delta is positive, the roots will be real. Since delta is positive, Therefore, the roots are real. That was the question. I am giving one more question here, please see. I don't want to solve this question, very simple, please solve on the same lines.